Okay, good morning. Welcome to
KidMath number 175.
KidMath number 175. Today we're going to do our second video about the logistic equation that was inspired by some awesome videos that Steven Strogatz put online. Yeah, let me grab that purple marker. I just forgot to bring the second marker, thanks. We're going to look at this specific equation. X sub n plus 1 equals 3x sub n times 1 minus x sub n. Okay, and if we put in some values into this, what value do you want to start with, just for as an
Let's
example?
start with a half.
Okay, x sub 0 equals a half. Okay, how do we find out what x sub 1 equals?
Well, we say x sub n is a half.
Okay.
So that's this.
Yeah. So
So
how
we get 3
times
times a half
a half
times a half.
times a half, and that equals
That's 3/4.
3/4. Okay. And then we can, if we wanted to compute what x2 was, we could just keep computing. Okay? But computing is a little cumbersome, and I'm going to show you something really amazing, a really neat connection between geometry and algebra. So if we were to draw this equation, y equals 3 times x times 1 minus x, what kind of equation is that?
It's a quadratic.
It's a quadratic. Okay, where are the zeros?
The zeros are 0 and 1.
And 0 and 1. And the maximum value, or the minimum, depending on which way it goes, although this one opens down because it's a minus x squared.
Yeah.
So the maximum value is halfway in between at a half. And we already just saw that that goes to 3/4. Okay, right there. At 1/4, I get 3 times a fourth times 1/4, or
3
3 times a fourth times 3/4,
Yeah,
which is 9/16. 3 times a fourth.
which is a little bit above a half.
It's a little bit above a half, so let's call that, there's an eighth there, it's about right there. 3/4 will be the same, it'll be 3 times 3/4 times 1/4. So I go to there, I go up, and then down. Okay, maybe not the best parabola anyone's ever drawn, but that's okay. Now I'm also going to draw on the line y equals x, because I'm going to show you a really neat trick. So I want to be careful about how I draw my line y equals x. There's a fourth, there's a half, 3/4, 3/4 will be maybe about there. Does that look right? It's got to be level with that.
Yeah.
So it seems to just kind of go up like that. All right. Now let me show you what this iterative process that we're doing looks like geometrically. We start at a half, and that brings us to 3/4. Now normally we'd want to go down to 3/4 now and go up to the function, and we already calculated that actually.
Yeah.
Okay, and now that was 9/16, which is in between here, so maybe we'd make a little point.
Yeah.
A little point there, and then go up. But we actually can do it using, this is why I drew this line in. To convert y into x, this line y equals x does that for us. So I can go up. Let's do this in purple. Can you draw it going up? Now you go over to the function. Now specifically we know it's that dot. Now all of a sudden I have a new x value that we normally would put down here on the line, on the axis, but it's on that line.
So it goes
Now go over to the function. Put that into the function.
the line.
Sorry, go over to the line. The value of this, the y value, is 9/16, so we need to convert that into the x value, 9/16. Now go up to the function. Now go over to the line. Now down to the function. Over to the line. Up to the function. And we see this really amazingly cool behavior.
It's like a spiral. It seems like it's going to converge to here.
Well, maybe. We don't know.
Yeah.
It looks like it's maybe converging into there. Now pick another point. Now you can. The reason I wanted to show you this geometry is because computing this is hard.
Yeah.
But drawing the geometry, drawing the picture is actually really easy, and you can imagine it would be really easy to do this on a computer too. So pick any other point you want.
Let's go 4th.
Okay. So you go up to the function.
Right there.
Okay. Now go over to the line. Well, make sure you go straight, parallel to the bottom. Okay,
Like that.
so maybe about there. Okay, so now a fourth sends you to there.
To the function.
Yeah. Now go up to the function.
Up here.
Over to the line now. Where's that line? Okay.
It seems like it's in almost full in sync with this.
Yeah, it seems like we've ended up at exactly the same spot. And we're spiraling in. Okay, let's do one more, and then that'll be the end of our video. Let's see if all points kind of go to the same place. Pick a crazy point.
That one.
There. Okay. So go up to the function. Now you have a y value. Now you need to convert it into an x value over to the line. Okay, now you have an x value. Convert it to a y value. Okay.
Well, it's gonna
Look at that. They all keep getting kind of sucked into that. Looks like they're getting sucked in around that intersection point.
Looks like it's like a black hole.
It does kind of look like a black hole. Pretty cool, right?
Yeah.
So it's amazing that the geometry tells an amazing story here that appears to be very difficult to compute, although with a computer we can compute it very, very quickly. This is really neat. And the one thing I just wanted to end with on this today is that this got going, I was watching some of his lectures yesterday. The study of this got going in like 1975, so about 30 years ago.
That's pretty
So
recent.
this is pretty recent now. So actually, believe it or not, they don't know a ton about this. The quadratic formula that you might use to solve this equation was like 1,000 years ago. This is only 30 years ago. So this is, we're getting close to some pretty brand new math. And yet, it's fun to play around with, isn't it?
Yeah.
It's fun. All right. Good job, sweetie. Good job.